In mathematics, scatter graphs, also known as scatter plots, are used to display and examine relationships between two variables. Each variable is represented along one of the two axes, with one typically assigned to the horizontal x-axis and the other to the vertical y-axis. Each pair of values from the dataset is then plotted as a single point on the graph, allowing for a visual exploration of any patterns or relationships. Scatter graphs are particularly useful in showing correlations, revealing whether there is a relationship between the variables and, if so, the strength and direction of that relationship. When interpreting scatter graphs, the first feature to observe is the overall pattern of the points. If the points appear to form a line that slopes upward from left to right, this indicates a positive correlation, meaning that as one variable increases, the other also tends to increase. For example, in a scatter graph plotting hours studied against exam scores, we might see a positive correlation, as more study hours generally lead to higher scores. Conversely, a downward-sloping pattern from left to right indicates a negative correlation, where an increase in one variable is associated with a decrease in the other. An example of a negative correlation might be the relationship between the speed of a car and the time taken to complete a journey. The faster the speed, the less time the journey takes. If the points appear scattered without any clear pattern, this suggests no correlation, meaning that there is no apparent relationship between the two variables. The strength of a correlation can also be assessed visually. When the points closely follow a straight line, whether sloping up or down, the correlation is considered strong, as the variables show a consistent relationship. A weaker correlation is indicated by points that are more dispersed around a general trend, suggesting that the relationship between the variables is less predictable. Scatter graphs are often used as a preliminary tool to determine whether a further statistical analysis is needed to measure correlation strength more precisely. In some cases, scatter graphs may reveal a nonlinear relationship, where the pattern of points follows a curve rather than a straight line. Nonlinear relationships can show that one variable changes in a more complex way with respect to the other, such as exponential growth, where values rise more rapidly as they increase. Although scatter graphs are typically associated with linear trends, nonlinear patterns can be highly informative, highlighting relationships that might not be evident in other types of graphs. To enhance interpretation, a line of best fit or trend line is often added to a scatter graph. This is a straight line that runs through the data points in such a way as to represent the overall direction of the relationship, minimizing the distance between the points and the line itself. The line of best fit helps to clarify the trend by smoothing out any random fluctuations in the data, making it easier to identify the direction and general strength of the correlation. Once drawn, the line of best fit can be used to make predictions about values outside the dataset, a process known as extrapolation, or to estimate values within the range of the data, known as interpolation. For example, in a scatter graph showing the relationship between temperature and ice cream sales, we could use the line of best fit to predict sales on a particularly hot day, even if that temperature wasn't included in the original data set. It is essential to remember that correlation does not imply causation. A scatter graph might show a strong correlation between two variables, but this does not necessarily mean that one variable causes the other to change. There may be other factors involved, or the relationship could be coincidental. For instance, while a scatter graph might reveal a correlation between ice cream sales and sunburn cases, it does not mean that buying ice cream causes sunburn. Rather, both may be influenced by the hot weather. Scatter graphs are valuable across many fields, from economics and social sciences to biology and physics, wherever relationships between variables need to be analyzed. They allow us to summarize complex data in a straightforward, visual way, providing immediate insights into relationships, trends, and outliers. Scatter graphs are particularly effective in identifying outliers, or data points that fall significantly outside the general pattern, which may indicate unusual cases or errors in data collection. By making relationships and patterns accessible and understandable, scatter graphs serve as a versatile tool for both simple and advanced data analysis, offering clarity and insight that numerical data alone may not readily reveal.